All right, folks, good morning, everyone, and welcome back to this on this beautiful Sunday morning. Surely our lectures and our sessions are far more exciting than the beautiful weather outside, isn't it? All right. So anyway, jokes apart, I hope you guys are having fun with the project. Now, first thing I wanted to know, how many of you are mostly done with project one?
Was it semantic search?
Yeah, not just the semantic search, all the way to RAG and not yet. Are you guys facing any roadblocks? Do you need any help or any tips from that? Or you think you're making steady progress? How many of you finished the semantic search part of it? You're getting the semantic search results. If you got the semantic search results, then what is there? After that, how many of you could feed it into a transformer and get a response from the transformer? How many of you could do that? Because that is the easy part, isn't it?
So I put together things in pieces now. So
okay.
Enough. Yeah, having a bit of struggle in the fashion basis of the database, right? Integrating that.
Okay.
So, but we've got, like Dennis was saying, I think some of the individual pieces are in place.
Right. Do that, and then I'll give you guys a slightly different exercise on that. So guys, do that. When you do that, make sure that into your index, you not only put text, you also put images and make it multimodal search, and then put your RAG. How many of you are making, one second, how many of you are making a Streamlit UI on top of it? Good. How many of you are doing it in React itself? And how many of you haven't reached there at all? Okay, so you guys need to buck up, guys. I am inclined to slow down. If you see in this course, and the field is moving very, very fast, right? The first course was not supposed to be, actually at the end of it, when you come to LLM Bootcamp 2, you'll realize that this course was the easy one. It was just, it feels hard because it's breadth first. Like I'm teaching you a whole breadth of topics, introducing you to a lot of things, right? And so it's a little bit, somewhat like undergraduate education. In undergraduates, you take undergraduate school, like college, you take a lot of courses, right? But in none of the courses you go deep. It's like in every course you stay at the kindergarten, every topic you stay at more or less the kindergarten level. Right? And then when you go to grad school, it suddenly sinks in that something you thought you knew really well, you have barely scratched the surface. Right? Somewhat like that. So the Bootcamp 1, if you notice, it is proving to you a little bit hard to catch up because I'm covering a lot of topics. It's a vast array of topics that we are covering. The purpose was to introduce you to all of these, not necessarily in the most efficient or the most professional or the deepest ways, but guys, please mute yourself. I'm getting echoes. Okay, so, but at enough level that you get introduced to it and you are productive. Are we together? Right? You get productive. You can use it in your workplace. You can do something with it. Right? And these are all the hot topics of these days. So guys, in this course, the most important topic is semantic search, RAG, right? Some basic prompting, and multimodal learning. Are we together? And LLM ops, the ML ops. Now, if you become good at only one of these things, not all, just one of these things, trust me, at this particular moment, there is, if you're looking for job opportunities, there is a job opportunity. I'm not exaggerating when I said that the last cohort, there is not a single person who did not achieve whatever the stated career goal was, either starting AI teams internally, AI projects internally, looking out for jobs, doing startups. They all succeeded. They all succeeded very well. But it takes time, it takes effort. Ideally, I would have liked to see you all completely sleepless and deeply frustrated.
Right? The second part is true.
Second part is true. Okay. Yeah. See, this is what I don't know. It's one of the things you go to when you go to grad school in US, in some of the top universities. This is what they do. They just make sure that from the day you enter the department, to the day you walk away with your graduation certificate, it is endless misery. Right? You're all the time chasing deadlines, all the time, drinking from a fire hose. Well, thank goodness we are not in grad school, isn't it? This is just a much more relaxed atmosphere. But I hope that you guys are feeling somewhat stretched, because that was the goal. You learn best when you are stretched and you feel you are behind. So, with all of that, let's cover the topics we have done. We have done semantic search. We went through transformers. Yeah, one more thing I wanted to mention on transformers. I think I mentioned this before. There's this video that three blue, one brown is something I've been talking to you guys for many years. You notice that I posted in the Tuesday class. I've been talking to you about it right from the beginning. And in over the years, I really appreciated. There are three particular groups that have done very well in educational theory, or the propagation of it, like spreading dissemination of good mathematical knowledge. One of them is obviously three blue, one brown. Absolutely amazing when it comes to explaining any concept that is mathematical. I think they do a very, very good job. The other one that I can think of is, but at a much more basic level, is the Khan Academy. Right? So Khan Academy is obviously Salman Khan's, or as he calls himself, Americanized Sal Khan. Right. He's from Calcutta, apparently. So that is very good. Then obviously Coursera is the third one that has led to a lot of courses, very good quality courses on a lot of mathematical, and not just about every topic that you can imagine. Right? There's a couple of other ones. If you want me to put a compilation of the things that I like best, I can put it. One of them is StatQuest. Right? I don't know how many of you are aware of StatQuest. It's very, very good, and many, many concepts are explained in a simple way, with even a jingle in there and jokes and everything in there. It's very nice, very nicely done. Another one that I can think of is a Mathematical Monk, another good channel. So these are some of the channels. The basic rule is, guys, they put in a lot of effort. A 15-minute video that they produce has probably taken them more than a week of effort to produce, or more than that. Right? So especially three blue, one brown, each of their videos, I would say, has taken a month of effort to produce. Right? And a whole team of effort goes into it before videos of this high quality come out. When they do come out, please do. These are drills that are essentially given to you free. Right? Do watch them and benefit from them. They're really very good. Right? I wish I could make visualizations as good, as nice as they do, but it's just enviable how well they do it. Absolutely marvelous. So do please go and avail yourself of this. Now, going back to the transformers, we covered transformers. We did streamlets basically, and chainlets. Those are tools. We did approximate ANN methods. What does ANN stand for? Approximate nearest neighbors. And why do we need approximation? Why approximate?
It takes much time or resources.
Yeah. You trade off. It's a trade-off. You give up a little bit of accuracy. Yeah. From practical perspective, it doesn't really lose anything, but you gain orders of magnitude, for 3, 4, 5, 6 orders of magnitude of speed, retrieval speed. Right? So to wit, if you have 100 billion images, you cannot do an exact search in that. It would be preposterous to do it. Right? No hardware will sustain a web scale traffic with 100 billion images, for example. Right? And yet, these days, ANN engine can, or FAST, or any one of these high performance ANN engine can return to you the results in sub-milliseconds. Right? Just think about it, sub-milliseconds. Right? It shows the tremendous might of the algorithms these days, how things that were unbelievable a few years ago are realities today. Right? It also speaks to, in my mind, the quiet revolution in the mathematical foundations and the theory behind a lot of this that has been going on. Continual improvement. It keeps on getting better and better and better. Like hardware keeps getting better. The systems architecture keeps getting better. The algorithms keep getting better with the math foundation. Everything keeps getting better, and it is all accelerating. So in many, many fields, more breakthroughs have happened in the last 2 years than in the entire history of the subject. Certainly AI is one of them. Right? So it speaks to that. Promptly done. We did basics of prompting, the CoStar framework. We did RAG. What was RAG?
Retrieval augmented generation.
Right. It's a retrieval augmented generation. And what were some of the primary benefits of doing RAG?
To produce a more meaningful response by giving a context to the LLM saying
Good. That is one answer.
Up-to-date information and also
more up-to-date information. That is good, because if your model was trained on date X, all information that came after date X, it wouldn't know. So it is the trade-off between the retrieved memory, the parametric, what the parametric memory of the LLM knows versus what you can augment it with through a search retrieval. What else is the benefit of RAG? Anyone remote would like to chime in? I heard a voice speaker.
Domain-specific knowledge. You can train with domain-specific.
Yeah, but why can't you fine-tune an LLM with it?
ground truth.
Ground truth means what?
Ensuring that the information you produce, it's not
hallucination. It mitigates hallucination by giving it the ground truth, by giving it some things based in facts. And if you're clever with your prompt, you can force it to produce evidence from the search results and then only speak something, right? Like every statement that it makes in response, the LLM makes, must be grounded in the search results. You can force it to do that. That significantly mitigates hallucination. That's an important consideration. And so there's always a trade-off between RAG and fine-tuning. So why not just fine-tune the model with all the data?
It's very expensive.
It's expensive. Yes, it is expensive, but then you can say, I can lower it. It's not that bad. What then?
Then you're overfitting the model?
No. See, whenever you fine-tune, it comes with this attendant risk. Right? If you're not careful, if your data distribution is at great variance from the underlying data with which it was pre-trained, there can be a risk of catastrophic forgetting, which is, you mitigate that with techniques like PFT, techniques like LoRa, etc., in which it doesn't happen, but still it costs hardware to do that. But another security reason is LLMs, whatever they learn, whatever you train them on, they can give it back to you. So people can extract that information out of it, especially confidential information. You don't want to fine-tune your LLM with confidential information, even if you think your LLM is way hidden from the outside world, because all it takes is one guy's access to it before it starts regurgitating a lot of the training data that it has. So there are many considerations, but generally the gold standard is to both RAG and fine-tune at the same time. Pick what you need to fine-tune it with, and the rest of it, just RAG it. Visual language understanding, we talked about that, right? And we talked about how transformers can be used to the visual domain. And from there, not just the visual domain, we can do visual embeddings, we can do image captioning, clip, etc. from there onwards, so on and so forth. We did some projects. We also talked about the ML ops pipeline. Guys, this is a very, very big topic. You must, and some of you, I can assure you that if you have not been paying enough attention to MLOps, definitely, you're missing a crucial piece of the puzzle. You may build the best models. At the end of it, business is about taking it to production. If you can't take your model to production, forget about it. Forget about all your creativity. It's like, living in an ivory tower. Right? ML Ops is the bridge that takes things to production, creates feature stores, has pipelines for data coming in. Does that make sense, guys? Yeah. It is the whole pipeline, so take it very seriously. Ray is a good framework to do ML Ops. There are many emerging frameworks, and of course there are specific corporate frameworks. For example, NVIDIA's NIM, etc. They fit in somewhere in the ecosystem of ML Ops. You can learn about those too. Visual embeddings, image captions, we did clip. What else did we do? Blip 2, Lava, etc. We did that. You all did labs with Lava. Wasn't it impressive? Lava. How many of you were impressed with Lava? Very, very impressive, isn't it? It is. I mean, it's amazing. And one person, Patrick, actually did a very interesting thing. He solved a medical problem of skin dermatology problem. Google released a dermatology data set, and he took the dermatology data set to essentially train lava, fine-tune lava, such that it could, you would show it your skin, just point your cell phone to it or something like that. And it would immediately tell you what exactly is the problem you're having. Right? So pretty good thing. It's a sort of a basic triage that you can do at home, sort of thing. If you are interested in seeing how he did it, reach out to Patrick. But it's just fine-tuning lava. Much of the hard work, as often goes in preparing the data. So if you ask Patrick, where did he spend most of the time? Fine-tuning. Once you have the data, fine-tuning the model is, of course, so many lines of code. That's it. Right? But at the end of it, getting the data itself, you need a lot of ingenuity, programming, clever tricks before you can produce the data to fine-tune it. So he did that. We talked about Jenkins, we talked about Spark. These are things that you should be familiar with, guys. One thing you have to know, and this is a subtext that people forget, to train transformers, to train neural networks, or do things like that, especially if you're in the pre-training mode, that first of all, which is think twice before you pre-train. It's prohibitively expensive. But in any case, we're talking about data at scale. This modern world of AI runs on three big foundations: massive compute power, right? Massive data, and massive neural architectures, right? Huge parameter models. And to the extent that you have massive data, there was a word that used to be there for massive data, the whole field of handling massive data. What was it called? Big data. Yeah, big data. And Spark and PySpark and Spark was one of the leading frameworks to handle big data computation. Take it seriously, guys, because when you take it to scale, when you're trying to do anything real in your production world, in your company, you will often realize that data will come in terrible forms. You'll have to do a lot of large computations to rationalize the data and extract features from it. Right? So that's where the value of Spark is. We did Lava. Then recently we did Document AI. What in the world is Document AI?
Taking images of documents and
Yeah, looking at images of document and making head and tail out of it and extracting the information from it. The document may have logos, the document may have tables, may have figures, may have text. To be able to extract, may have handwriting on it. To be able to do that. So today we'll do the Document AI continued, and I'll give you guys a project which you guys have to do in small teams. Each of your teams, I need you to do this in the afternoon just to consolidate this knowledge. There are two projects you'll do. Take some receipts, right? And ideally, not that receipts that you have downloaded from Kaggle or Hugging Face. They are famous receipt databases, CORD and so forth. Don't go there. Worst case, go there, but then I'll consider you rather lazy. Right? Just pull out some receipts from your pocket, blacken out any sensitive information, take a picture of it, and I want each one of you to just do a mini project. Try at least two models that extracts all the information, produces a table, number one. Number two, does question answer on it. Does that make sense, guys? Two things. The second thing that I want you to do is I want you to handwrite some text, handwrite a story or handwrite something. And I want you to be able to do question answer on it. Right? So for example, the cow jumped over the moon. You could ask the question, who jumped over the moon? Right? And don't write it in beautiful, perfect handwriting. Like it shouldn't feel like fonts, capitalized fonts. Write it in sloppy handwriting. And it's a competition. Let's see which team comes out with the best question answer on handwriting. Does that make sense? And there's an actual price. Yeah, go ahead.
So this is not fine tuning the model. This is actually just an application, right?
No, I'm giving you an end problem. You're doing a startup. Imagine you're doing a small startup. One of them is to read receipts. And by the way, receipts cannot be perfectly square and nicely straight aligned and so forth, or put them at weird angles. Bonus points for crumpled up receipts. Right?
No, if you only want us to use our own receipts, we won't have many, right? So that's why I was asking you that.
Just go shopping at lunchtime. Right? So cook out some receipts amongst yourself and do it. But guys, don't borrow images from the internet. Don't go to the core data set and just pick up some. The reason is the model's already trained on them. Right? I want you to play with your own thing. See, guys, face real world challenge. Face real world challenge. Good thing would be you have a receipt in which, for example, there are some line items have been crossed and handwritten with different totals, and that is real life. Somebody gives you a 15% discount, strikes it out and says new price by hand, and gives you a total that you pay. You realize that, right? So how would you be able to read a real life receipt? I want you guys to do it before the end of the day. Do that, guys. These are the two projects for the day. Today, I want you guys to do it. We will have a competition. Each team will present. Right? Each team will get about, so we have 4 teams here, and I hope at least 3 teams remote. Let's give about 10 to 15 minutes per team to present. Does that make sense, guys? We will do that. So that is it. Now, one more thing I would like to say, that there is a remarkable two papers. One of the original, we said that optical character recognition used to initially be done with CNNs. I talked about the fact that we are transitioning from CNNs. A lot of increasingly, transformers are sort of becoming more and more prevalent. Still, CNNs haven't given up. There are many, many situations in which the CNNs are still holding pretty strong, right? So people are using both CNNs and transformers, and do that. One of the paper was the TR-OCR. Now today, deliberately, because I wanted to save time and I wanted you guys to spend time on implementation, I put the pre-recorded sessions from the TR-OCR paper, which I mentioned last time, that it was the use of transformers to do OCR. What was OCR? Optical character recognition. Now, as you can imagine, it's an encoder-decoder model. You can pretty much guess what its architecture would be. How would you do that, guys? If I give you some text, how would you do that? You would start with a visual transformer and then do what? Some form of visual transformer and do what? Feed those patches into some form of decoder. That's it, right? So do watch this video. Now, NOGAT is something pretty close to my heart, because a lot of scientific documents have a lot of mathematical notation. Right? Can we read those? Can we convert that? Not just understand that, but see, math is meaningless unless you can write it in LaTeX, right? Basic tech notation. Can you go and produce tech content out of it? This is a second paper. I'll leave it to you to do that. And then we come to the topic of today. There is something called segmentation. What is segmentation? Breaking up an image into its constituent parts, segmenting the image, right? Oh, this is a tree, this is the eye, this is the cat. Are we together? Now, there are many ways of doing segmentation, masking it, or putting bounding boxes, right? Giving a text description, identifying what it is, and so on and so forth. So segmentation has a sort of different components to it.
This one is not showing up on the Zoom.
Oh, I'm not sharing the screen. Okay, sorry. Thank you for pointing out. Yeah, so segmentation is important. This is a topic for today, but I don't want this topic to deter. Well, deter happens to be one of our papers to read, but let's not let segmentation not deter us from doing the project that I gave you guys. So we'll do the segmentation project next time. I put all the resources for segmentation here. We will really do it properly in a subsequent time. Time permitting, I would like to cover first two research papers. One is UNet, which was one of the very successful architectures for segmentation using CNN, and DETA, which was the very influential transformer-based architecture for object detection, right? And then came many things. For example, they came segment anything, the SAM, segment anything model from Facebook or Fair Research, and then segment anything took a transformer-based approach, and then somebody outdid it by coming up with a CNN-based approach to do the same thing faster, right? So you can see that in CNN has a lot of strengths, and it's one of the few architectures that's still holding up, right, and competing with transformers in situations. So we'll do that. Now, I would like you guys to see a couple of demos. First thing is segment anything. So this is a segment anything website. I want you to GitHub. You can just look at the images. What does it do? If you look at this, do you notice how it is able to mask or create the mask around objects and trees? Do you see it, guys? It does it very well. This is the segment anything paper. As you can imagine, it uses a, you will notice that it goes and the architecture is given. We'll do the research paper very carefully at some point, but at this moment, I've just left you with that. Right? It is implemented with a VIT. What is VIT? Visual transformer. Right? So it is using a visual transformer. On the other hand, the fast segment anything uses fast segment anything, says, no, wait a minute, we can do it faster and we can use the traditional CNN approach. Quite interesting, actually, how these things work out. And so there is a lot of, there's a way, segmentation is one of the most important tasks in computer vision. Right? You can imagine if you do a self-driving car, autonomous car, for example, what is the most important task you want to know? Is this empty road or is this a pedestrian walking on it? Isn't it? As simple as that. Yeah. So, so we will take the segmentation topic very seriously, but because I wanted us to make some practical progress today, I am keeping it for the tail end of today. We will do things. I will do 2 research paper readings, UNIT and this, data, and we'll cover hopefully some more ground next time. YOLO is one of the most popular and algorithms for segmentation that has been around. Things are changing. What is grounded SAM, grounded anything demo? It is quite interesting. This goes to the multimodal nature of it. Let's drop an image here. What would be a good image to drop? Let's here, and maybe this is a good image to drop. Let's go to the course portal and find an image. Okay. Let's see if I can drop it here. There we go. Here's an image. We ask it to detect multiple objects. We ask it to segment. People, robots. Let's see what it does. Look at this. This is the original image, isn't it, guys? It says people, 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 people. It found all these people. Right? Then you say robots, and it says that the same people are not really people, they're robots. Right? Isn't that good? Yeah, so this is grounding. And you could do a lot of in-painting, out-painting, remove. So, for example, you can say, remove the people and robot, or what remains? Let's see. There we go. This is the mask for people. and this is the image with the main transformer gone. You see that? And all the people that it could identify more or less disappeared. Isn't
So
it
this
amazing?
Is running on a T4.
What's that?
This is running at the back end or a T4, it says on top.
Oh,
So that was my question really, is in a lot of these, is the computation done locally on the machine or is it done on the cloud?
no. In this particular, because this is Hugging Face Spaces, it's running on the Hugging Face server. T4 is not a very powerful system, but guys, do you see how fast it went? So can you imagine how fast it will run on your private BW200? No, I'm kidding. Like on your whatever 4090 and 3090s that you have. So try this experiments. Play with this on your machines here. By the way, guys, we again got some more hardware. Sanjeev and Satyakam, are you hearing me?
Yes, I'm hearing you.
Yes. So for you, there's a brand new machine.
Perfect. Thank you so much. Yeah, I'm literally stuck because for me, when I was trying to run the donuts, Roy, and then it's just stopped, hanged on me, literally, like it was taking over one epoch, it was taking, or 0.01 epoch, it was taking literally half an hour to 45 minutes.
Okay. So that machine is dedicated to a team of you. There's one more member in your team, Prashant Gupta.
Okay.
And so take him together. And the three of you pretty much have that machine to yourself. It is a 24 GB GPU powerful machine. And everything is new in that. So go have fun with it.
Thank you so much, Asif.
Yeah. Is there any other team left without a machine?
Yeah, I would like to get one for my team. This is Sarah.
Oh, you guys have your own machine, right? Fancy machines.
Oh, we have laptops, but if you have one that's not used, that's a 4090, I'd like to be able to get some time on it.
Now we are out of machines, so we'll have to get some more. I just sort of assume that you guys have your machine. You keep because you mentioned that you guys have your own data center and servers. So,
Yeah, I just like to be able to play with a faster machine than what we have. So,
Sarah, what's your team name?
what's our team name? We haven't selected a team name.
You don't get a machine unless you have a team.
Yeah.
All right, we'll get right on.
Yeah.
Okay, we'll get you something. Good.
We'll get you something. So Satyakam, your machine name is the Cowboys.
Cowboys, okay.
At some point you were in Texas, isn't it?
No. Sanjeev used to be in Texas,
wasn't.
not any longer.
I thought to honor his location, Cowboys might be a good name for his machine.
How about we call ourselves the Eagles?
You can call yourself the Eagles if you want. You have a lot of.
Cowboys does just fine. No worries.
Okay. All right, guys. So the hardware is there. Go have fun with it. Guys, a lot of these things that you are seeing, do you realize that this is almost like magic that you can do it? Right? A few years ago, this was not possible. You could do in painting, you can do out painting, right? So, for example, in painting, out painting, if this is empty, then remove. Let's just say we can do it takes, obviously it's on a very slow hardware. So guys, look at this. What is it doing? It is also doing I don't know what it did. I don't know. Anyway, I'll let you guys play around with this demo. It has done something that I don't get. So getting back to our course, today's task, I hope, is clear. I've laid the foundation for what we're going to do later. Segmentation is an important task. We'll do that. Today, I'll cover 2 research papers, UNIT and DETA. There are 2 research papers that I want you to watch the videos of, which is in the previous day. The DETA and, the TR-OCR, right? The introduction of transformers to do OCR tasks, and the Naugat paper. There is also one more paper that I'll add the recording of, from the past. Again, I don't want to give time to doing that. See, suppose, where's my soda bottle? Where's my Coke bottle when I need it? Okay. So suppose you have this bottle here, right? And how many of you will be able to read the logo, especially if the logo is wrapped around the bottle? It will be hard, right? And that would be a really good task for it to do. So there are algorithms that can do that also, that do it very, very well. One of the algorithms that I did the research paper reading last time was text snake in the last cohort. I'll put the video of the text snake paper here. Watch that also, the recording of that. The only reason I'm not repeating those things is because I want to save time for you to do something practical. Are we together? If any of these topics you feel that the videos are not clear, you want me to do a live repeat of that, re-explain the papers, I'll be happy to do that. Does that make sense? Right. So watch these 3 videos at leisure. But today's task is this. What are the 2 tasks that I gave? Receipts. Original receipts, not copying from the internet. Guys, if you get a receipt from the internet, you bet it's part of one of the standard data sets, because they must have scraped it and put it there. Card or this or that data set. Pick an original receipt. First, just have it, read all the data from it, do question answers on it, ask it questions, talk to it, and then the next stage of the receipt is hand edit the receipt with something and write on it. See if it can recognize and answer questions if you edit the receipt with hand. The next thing is just take some handwritten text, write a little story, do whatever you want, right? And do visual question answer on it. Are we together? Let's do that. That is your project. We will have presentations from 3 o'clock. So I'm deliberately moving fast. That gives you 4 hours to implement these 2 things as teams. Does that look reasonable time, guys? Right? Just to give you a sense, if you knew how to do this, each of these would be 10-minute tasks, right? But the whole point is you don't know how to do it. You'll scour the web, you'll find ways to do it, and don't ask the neighboring team how they did it. The ideal thing would be each team uses a different approach to do it, right? So we all learn from each other. It would be nice. There are many, many ways of doing this problem, many, many models that you can use. Hopefully, you're all not going and picking the most obvious models, because that will be useless. But try out innovative approaches to solve the problem. We'll start our demonstrations at 3. You have 4 hours to do it. I'll come to your rooms, I'll help you without giving you the answers. Right? But if you get stuck, I'll help you. But take this time, do that. Okay, guys.